Hi, this is a video on how to make an unregulated voltage supply to a regulated voltage supply. And it's by Bartholomew Limburg, that's me, at Oregon Tech Institute. And first I'm just going to talk about how we're going to do it with an analog discovery too, and I want to talk about how I can get a 10 sine wave, an amplitude of 10 amps sine wave at 500 hertz. So, because that's what I'm going to need in order to use the Zener diode that I have that we'll be using at the end, and I'll explain that when we get to it. But here is the schematic. You can see the picture on the left is like a pictorial schematic. What I'm trying to do, we got a transformer. The AC line goes to the transformer, then a rectifier, a filter, a regulator, and the load. I don't have the equipment to do the transformer or the AC line, so we're going to skip over those and have a wave generator going right to the rectifier. But since the analog discovery only does a 5-volt sine wave, we're going to have to use a non-inverting op-amp in order to get it up to 10 volts of a peak-to-peak. And that's going to go right into the rectifier. So here's the next slide. You can see a non-inverting op-amp. There's the calculations. I'm going to want a gain of 2 because I can do 5. If you read the description on top, you'll see. And that's how I'm going to get my wave generator to get to where I want it to be. See, I picked out my resistance, R1 and R2, and I picked out my gain. So that's how I would do it from there. Okay, now I'll go back. Now I'm going to show you how to use a wave generator. First, I got to turn on my voltage source because I'm using an op-amp, so I got to have a negative voltage supply and a positive voltage supply to my op-amp. Here's my circuit. And right now you can see there's a lot of things on this breadboard, but the only thing that we're going to be doing right now is studying this op-amp in the back there. You can see I have a feedback resistor. Let's see if it'll focus. You can see I have an op-amp there with a feedback resistor. And all the wires are hooked up. This is all coming from my analog discovery. You see that little green light blinking? That means that it's on and it's connected. The 2 blue wires here is my first oscilloscope. That's actually the second oscilloscope. The orange ones is my second oscilloscope. I have the orange ones connected to the input wave generator, which is going to be this yellow one here. This is my wave generator of 5 volts sine wave. And the first oscilloscope is connected to that. The second oscilloscope is connected to the output on the op-amp to make sure that we are indeed getting a gain of 2 for an output of 10 volts sine wave. Now I'm going to go to the waveforms. This is the program that we use. Now here's our wave generator. And basically you can't read it that well. It's kind of hard to read with my phone, but it's at 5 amplitude and 500 hertz. And then my scope is showing the yellow line is going to be my first oscilloscope, and the blue line is going to be the second oscilloscope. So we're going to go ahead and turn on this wave generator, and then we'll turn on the scope, which you can see I already ran it before, but this is showing that I have a 5 amplitude for the yellow wave. See if it'll focus. There, it focused. And that's my input to the op-amp. And the output of the op-amp is 10 volts sine wave. So indeed, the first part of this analysis did work as we wanted it to, and this is how you get your analog discovery to work for getting a higher output voltage. Now we do have the diodes on this breadboard and another op-amp, but we're not going to do all that with this video. I will just show you some pictures with my PowerPoint and explain how we went from this point to the next point. So let's get back into presentation mode. Alright, now that's the op-amp that I was just showing you, and that worked as expected. Here's the diode, and let's show you. This rectifier, we have see that arrow pointing to the rectifier? That's going to be our 10 volt sine wave, and that rectifier is the next part of this project. And here's a blown up picture of it. So we're looking at a silicone full wave rectifier, and we're expecting to get a frequency that's going to be twice as fast, and it's going to look like that picture up in the upper right hand side. And we're expecting an 8.6 volts because there's going to be a 0.07 volt drop for each diode that it goes through, and there's going to be 2 diodes that the positive and the negative sine wave go through. Now the next part of this is to have a ripple voltage. The ripple voltage is basically we're going to be adding a capacitor to our circuit with the resistant load at the end in order to keep the voltage above a certain point. If we can keep the voltage above a certain point, our Zener diode will work correctly when we use it later for regulating the unregulated voltage source. If you look at this picture down on the left, that graph is showing how a capacitor will change what we're going to be seeing when we do the simulation or the experiment. Now, the analog discovery can be pretty difficult to use. There's not a lot of information on it, but if you see that website on top there, that is a very useful website. It helped me out a lot when I was going to build my full wave